This week on QDL, we have a tech corner for you today, and what we're going to be looking at is the Vanta XRF analyzer. This is a tool that allows you to do material analysis in alloy composition, so you don't want to miss that. Come back and join us in 30 seconds. Welcome back to QDL. QDL is your weekly look at who and what is making news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest, and joining us today is Michael Hull, Product Manager with Olympus. And you've brought a Vanta with you.
Yeah, indeed.
And XRF Analyzer. Why don't you tell us, well, first of all, what does an XRF Analyzer even do?
Yeah, so this is for material analysis. You can use it on almost any material in the world. Okay, most commonly, it's going to be used for metal analysis. It uses X-rays to analyze the composition of the material, and when you know the composition, then you can verify that you've got the right material in the right place.
Okay, and show us how it works.
Yeah, it's very simple to use. It's handheld, it's portable, battery operated, so you can take it almost anywhere. Take it out into the plant, and take it out into the yard, take it out in the field. Simple handheld. Just place the instrument down on the sample. Pull the trigger, 1 to 2 seconds, you've got your material identification here.
And I noticed there was a light flashing at the top of that. What was that about?
Yeah, so simple light just to let the technician know when the test is being taken, and when this light stops flashing, then the test
you're
is
done.
over.
Okay.
Yeah.
Gotcha.
So very fast test time. And this shows here, we got a material that's, this is 304 stainless steel. It's an exact match for the material. Okay.
So I notice also you've got these bars coming down. This is the actual composition?
Yeah. So it's going to start with the chemistry, show you how much iron, chrome, nickel's in the material. But then it takes that composition and compares it to the industry standards or the industry specifications. Most users aren't chemists. That's not a problem at all.
Okay.
The industry specifications are already pre-programmed into the instrument. You can do the comparison. So in this case, this is a stainless steel. There's a lot of iron content. Chromium needs to be between 18 and 20. Nickel needs to be between 8 and 10. This is a typical 18-8 kind of stainless steel. And it's a typical simple red light, stoplight type of interpretation. Green means good, red means bad. And the chemistry's in the green zone, it's good. And then it does that comparison interpretation for you and puts the match up at the top.
Now, if you had, so these are industry standard limits, I'm assuming, for stainless 304. If you had your own formulation, you could change the limits to whatever you wanted. You're not stuck with what's the default is, right?
Yeah, absolutely.
Okay.
So we try to give the user flexibility and do the pre-work for them. So the instrument comes with about 750 of the most common alloys pre-programmed, but the customer can put in their own alloys or their own specifications. If they have a more stringent requirement than the industry standard, they can change those requirements. Or if they want to put in some proprietary formulation or a new alloy composition, they can put that right in. Do it all right on the analyzer, just a few finger swipes on the instrument.
Okay. And let's take a look. This doesn't look like, this looks like maybe copper?
Yeah, yeah.
Okay.
So I think this is a phosphor bronze, but
bronze?
I don't have
Okay.
to. I don't have to know myself.
You don't have to know.
Right, I'll just pull.
You got the tool
analyzer.
for that.
So again, we put the specification up on the screen. This is a copper 510. This is a phosphor bronze. And again, the technician, if they're knowledgeable about metallurgy and chemistry, good. If they're not, we try to make the interpretation simple. It's easy to do. Pull the trigger, 1 to 2 seconds. We've identified this as copper 510 phosphor bronze.
No, you said, can this be set up for pass-fail?
Yeah.
So that you don't have to go through there and look at the bars and all that stuff.
So we're right away doing the comparison already.
Okay.
But it's sort of like the TSA problem. You can have scanner fatigue, right? As
right.
Parts go through. Let's say they have to verify a whole lot, 100 parts or 1,000 parts. It'd be easy to miss that. So you can set up a simple pass-fail. We just go into the instrument. We go to pass-fail. Let's choose, let's say, a stainless steel. All the alloys are pre-programmed in there for you. Choose a stainless steel. Let's say we were expecting that this batch should all be 15.5, a particular stainless steel alloy. Okay. Technician's moving along. 15.5. like they expect. Says pass 15.5.
Okay, right up
green
here,
means
right up here at the top. Okay,
right in there,
gotcha.
good. Right, green means good. And you know, again, all these metals look similar.
They all look shiny, like shiny little pieces of metal.
That's right.
Exactly.
So grab another component. Maybe there's some kind of mix-up. Pull the trigger. Right there, bright red. Failed. This is not a piece of 15.5. Tells you what it is. Can move the compartment.
So very quick. They just go through and they don't have to look at the bars or anything. You just pass fail.
Right.
Okay.
This is designed to be easy, fast. You have high throughput, simple for the operators.
Okay.
And it's really important in manufacturing because mix-ups can happen at a lot of stages. It may happen at incoming material. You want to verify that what the vendor said they sent you, they did in fact send you. It's kind of trust but verify. But from there, you know, maybe it gets unloaded. Fork truck driver puts it in with raw materials or something like that. Label falls off, gets mixed up. Could be simple human error. Right? Go to do them, put it on the assembly line or manufacturing, put it on the mill or lathe. You want to make sure you're using the right material. And before it goes out the door, do verification at each steps, depending upon the quality control program that the manufacturer needs.
And I guess it could also be used for sorting. If for some reason you had you had materials that got mixed up or something like that, you could very quickly just go through and identify, because like you said, they all just look like shiny metal. So
right. Yeah, definitely. So there's applications for the analyzers in the whole metals cycle, from the mill and the furnace, verifying the metallurgy, to the manufacturer, making sure they have the right alloy in the right place. Preventing costly mix-up there, and then even as at the recyclers where the component is being disposed of, mix it.
I hadn't even thought about recycling. Sure, of course, yeah. Okay.
To mix the different, or separate the different components that have been all kind of piled together, and then send it back off to the mill, and that metal cycle starts all over again.
Now, is this being used in automation at all? Inline processing, that sort of thing?
Yeah, so it's actually possible to automate the analyzer. We've had customers do that where they've got an assembly line or maybe a robotic system where the part is brought by. Computer initiates
triggers the
computer initiates bringing the part.
Okay.
Computer initiates the instrument taking a scan. Do that pass-fail determination. Send the answer back to the computer. If the part's good, moves on down the assembly line. If it's bad, robot grabs it, puts it aside. So it's easy to integrate into inline systems as well.
Okay, and I'm assuming that's cabled or Wi-Fi or both, or
yeah. So the instruments battery operated in inline context. They often plug the instrument in, have AC power, can run it continuously that way, 24/7. Okay. The instrument can be connected by a cable, but it can also be connected wirelessly. So you don't even have to have a cable to connect to the instrument. So you can send commands to the instrument or get data off the instrument all wirelessly without even having to connect it to a computer.
Okay.
Data management's pretty easy because we have a couple USB ports. You can send all your results to a USB stick, stick it in your computer just like we traditionally.
Just offload it, and okay.
Exactly. But if you want to connect it wirelessly, that's an option as well. Many kind of modern manufacturers, manufacturing 4.0, have their plants all wireless. They may have a QC computer program and they want to track parts continuously.
I was going to ask, in the hands of somebody like me who constantly drops things and uses equipment, for hammers when they shouldn't be used hammers, how rugged is the Vanta? I'm assuming it's got some sort of IP rating, and tell us about just the equipment itself.
Yeah, that's a great question. I mean, cost of ownership is an important issue when deciding on an analyzer. You want an instrument that's going to work as hard as you do and stick up. So the Vanta passes the military standard 810G. It's a 4-foot drop test. We don't encourage to drop the analyzer, right? But it's like your cell phone. No one intentionally drops it, but if you do, it should be able to take the fall and keep going. Ingress protection, you're right. You can hit this with splashing water, power washers, rain, mist, humidity, dust, no problem. So you can use it in a clean, modern manufacturing facility. You can take it out into the yard, take the scrap yard. Shipping and receiving, you've got fork trucks in a gravel parking lot. You can take it out there in the dust and the weather and the elements there.
Well, let's talk about some other uses. I mean, since you mentioned those, initially you were talking about kind of manufacturing floor uses, incoming inspection, maybe sorting, automated, inline processing, that sort of thing. But you also, I think, mentioned to me earlier that this is also used in process industries like oil refineries, that sort of stuff. So tell about the usages there.
Yeah, certainly oil and gas and pipeline, petrochemical, plastics industries. These all use it. It's the same basic concept of positive material identification. You're verifying that you're using the right material in the right place.
But I mean, you're not in the oil industry. Let's say you're not measuring. I mean, what do they measure? You're not measuring oil, or you're not measuring plastic. Right? I mean, what are they being used for in those industries?
Yeah, so most often they're going to be used to again measure the metal alloy itself to make sure that the pipe or the elbow.
Oh, the pipes. Okay,
yeah.
the equipment. Oh, so the processing equipment. In other words.
Yeah,
okay.
Exactly.
Okay.
So if the wrong component gets installed, it may corrode at an accelerated rate, may have some type of failure. Again, there's danger to human life, danger to the environment there if we have a component fail, as well as lost time and resources.
So I hadn't thought about that. So in a process industry, they're concerned with the equipment that's doing the processing, because if it's the wrong material, it may break down too fast, or it may I don't know, might contaminate. Might contaminate what's going through it. That idea, right?
Yeah,
Okay.
certainly. As you think about in the chemical or petrochemical industry, there's some pretty corrosive stuff going through the pipes. Could be acid, could be the petroleum products or the solvents that go through. Okay. And if the wrong alloy is used, there can be negative reactions with the material passing through the pipe.
Okay. And what about thickness? Can you measure? Not just composition, but the thickness. So if you had a coated, some sort of coated product.
Yeah, absolutely. Okay. So, typically we're thinking about using the instrument for composition analysis, but we can also use it for coatings thickness or coatings weights. So it's the same basic hardware, same basic X-ray physics, just have a calibration designed to measure thickness instead of composition. So this would be really common in the electroplating industry. So I have here this sample here.
Just a zinc washer, right?
Yeah, it looks like a piece of galvanized washer. I just again pull the trigger. Instantaneously here, less than 1 second, we're reporting that this is a zinc coating over top of a steel substrate, about 63 micro inches.
It's interesting. So it's looking for the boundary between two different types of materials, and through some sort of magic, it can tell where that boundary is located from the surface.
Yeah. So the thicker the coating, the more X-rays that are going to come off, and we can convert that kind of the X-ray intensity to X-ray to coating thickness.
Oh, interesting. Okay.
Yeah.
So that's cool.
Yeah, and it's really simple. We can do all sorts of micro inches or microns or coating weights like milligrams per square centimeter. So this is really helpful. Here's this galvanized, which is pretty common in everyday life, but even nickel coatings or shiny chrome coatings, cadmium on some bearings.
What about, is it being used at all, the Vanta, is it being used at all for, I don't know, like a consumer application, like, I don't know, toys? Every Christmas we talk about, another batch of toys has got lead or something in it, or I don't know, maybe I don't know, like in Flint, right? I mean, could they go up to a pipe and examine a pipe and say, oh, that pipe's got lead in it, or that sort of thing? Yeah.
So certainly, again, an alloy composition of a pipe, that's easy to do by X-rays, and consumer products as well. So we want to keep ourselves safe, keep our children safe. So we want to make sure that teddy bear we give to our nephew doesn't have heavy metals or toxic material on it. So another form of material identification or material verification. In this case, we're verifying that certain things are absent. There's no mercury or cadmium or chrome or lead, these sorts of toxic metals. And
is the same instrument every time, or is it? Do you have to buy a different one for different uses?
Yeah. So in general, the hardware is the same. We have an X-ray tube and an X-ray detector, and then the instrument can be specialized mostly by software for different types of applications. So
you would, if you were buying a Vanta, you'd be asked, well, what is your application? Then it would be set up for that specific. If it was toys or, like we said, whatever type of inspection you're doing, it would be the software would be in it for doing that.
Exactly. What question do you want to answer?
Right. Okay.
And then there's packages there to make that easy. And particularly in the case of consumer products or electronics, there's a lot of regulations around that. Have a simple, again, pass-fail interface where the pass-fail have been set to the regulatory requirements.
And finally, what's kind of the most interesting application you've seen it used for?
Well, you know, I'm really intrigued by manufacturing.
Okay.
You know, it's neat to see something being built.
Right.
And so I've worked with customers who've taken this and integrated it in line, taken this instrument, put it in with a robot, and they're making things and they're building a product that comes off at the end of the assembly line. And I'm kind of excited to see where kind of manufacturing 4.0 goes, kind of smart manufacturing. And it's neat to see the Vanta be a part of that. I mean, one of the things that's really important in modern manufacturing is data management. And so it's really easy on the Vanta to put in lots of information, and it's not onerous for the user at all. So we have a simple notes interface where the customer can put in various details about the sample that they want to they want to analyze, maybe what batch it came from or what lot, who the vendor is, who the technician was, whether it's a pass, fail, and these notes can go into the records for the part, you know, the data management system. And since the instrument can be wireless and send those results wirelessly in real time, as modern manufacturing, the part can move down without ever having to stop for data entry.
Okay. And I think you told me also this can do barcode scanning as well, right?
That's right. So and again, we try to make it easy for the technician. We don't want them to, you know, forget a step or what they have to do. So again, place it down on the sample. Pull the trigger. You can set the notes to come up automatically.
Okay.
And put in the information, and these fields can be set up. The instrument has an optional panoramic camera. Just click in the field, camera comes up, scan the barcode, and the information goes into those notes fields. It gets recorded with the results. So again, in modern manufacturing, if items are tagged, you have different lots and batch, put that information into a QR code or a 2D barcode.
So QR as well. Okay, all right.
Yep, all the modern forms of data management.
All right, well, very interesting. I appreciate you bringing that by.
Yeah, my pleasure.
Michael Hove with Olympus, and that is the Vanta XRF analyzer. I have that right?
Yep, that's correct.
Okay, and if you need more information on it, there is a link underneath the player page down there that'll take you out to the Vanta XRF page on the Olympus website, and you can read more about it. So, Michael, appreciate
Thank you,
and showing that to
I
us.
appreciate it.
And that is it for today's Quality Digest Live, QDL. Thanks for joining us, and be sure to join us next week, and we'll have something exciting to show you. Join us then. So long.